Welcome to Nap Labs, your quiet corner of YouTube. You're in a safe, gentle place now, where the universe feels close, curiosity stays soft, and peaceful exploration unfolds at a sleepy pace. These nightly journeys are here to help your mind loosen, drift, and learn something new while you rest. I hope you're nestled in a familiar room, curtains drawn against the evening. Maybe you're listening through headphones, the world reduced to just this voice and your breathing. Close your eyes if you haven't already, or let them rest softly on a distant point. Tonight, we're going on a journey together, a slow drift through space and time, to visit the smallest wanderer in our cosmic neighborhood, the ancient messenger planet, Mercury. Even its name moves quickly through the mouth, sharp and bright. But tonight, we'll move slowly through its story, lingering in the details like light lingering on water at dusk. Imagine yourself floating in the vast emptiness of space, that profound darkness between worlds. You're comfortable here, impossibly so, suspended in the gentle void. Before you, the sun burns with patient fury, though from this distance, its light is merely warm, not harsh. It's a reminder that our star, which seems so constant from Earth, is truly a sphere of ongoing transformation, fusing hydrogen into helium, 400 million tons every single second, pouring light into the emptiness. And there, moving against that brightness, you see it. A small grey sphere, scarred and ancient, sliding across the face of day. Mercury, the innermost planet, beginning another swift orbit that will take it around the Sun in just 88 Earth days. While our planet leisurely completes its yearly journey, Mercury has already circled the Sun more than 4 times, a cosmic sprinter running endless laps. This little world is named for the Roman god Mercurius, known to the Greeks as Hermes, the messenger deity who wore winged sandals and carried communications between gods and mortals. The ancients watched this bright point of light appear and disappear in the dawn and dusk skies, never straying far from the sun, moving faster than any other wandering star they could observe. They understood something fundamental about it, that it possessed a quality of swiftness, of transition, of being perpetually in motion between states. The Babylonians knew it by different names, depending on whether it appeared in morning or evening. The Mayans tracked its movements with careful attention, incorporating its cycles into their calendar systems. If you could somehow stand on Mercury's surface, equipped with the impossible protections that would allow such a thing, you would witness one of the strangest day-night cycles in all the solar system. Because Mercury takes 58 Earth days to rotate once on its axis, but only 88 days to complete its orbit, something peculiar happens. The relationship between its spin and its orbit creates a day on Mercury that lasts 176 Earth days, from one sunrise to the next sunrise. Imagine that, a morning that stretches across months. You could watch the sun rise, impossibly slow, and if you stayed in one spot, you wouldn't see it set again for nearly 3 of our months. The sun would climb incrementally across the black sky, growing larger and smaller as Mercury's elliptical orbit brought it closer and farther from that burning sphere. And then finally, after all that time, it would begin its long descent toward the opposite horizon. The surface beneath your feet would be a study in contrast, a landscape sculpted by 4 billion years of cosmic violence and patient, grinding time. Mercury's crust is ancient, among the oldest surfaces in the solar system still visible to us. Unlike Earth, where plate tectonics and weather constantly resurface and renew, where water erodes and life transforms, Mercury has remained largely unchanged since the solar system's violent youth. The rocks beneath you would be similar in some ways to Earth's basaltic stone, dark and once molten, but changed by billions of years of temperature extremes and micrometeorite impacts. The ground would be covered in regolith, a fine dust created by eons of bombardment, soft as powder, grey as old ash. Look around this dreamscape, this alien morning. The horizon curves more sharply here than on Earth because Mercury is smaller, only slightly larger than our moon, with a diameter of just over 3,000 miles. If Earth were a basketball, Mercury would be a tennis ball. Yet despite its small size, Mercury is dense, unusually so. It weighs in at about the same density as Earth, which suggests something interesting about its interior. While Earth's density comes from having a large iron core, plus a thick rocky mantle, Mercury's similar density, despite its smaller size, means it must be proportionally more iron than rock. In fact, scientists believe that Mercury's iron core is enormous relative to its size, making up perhaps 85% of the planet's radius. If Mercury were transparent, you'd see this massive metallic heart, larger in proportion to the planet's size than any other world we know. It's as if Mercury is mostly iron wrapped in a thin shell of stone, a cosmic cannonball, heavy and compact and swift. Why would Mercury be built this way, so iron-rich, so dense? The story might begin 4.5 billion years ago, in the early chaos of the solar system's formation. Picture a time when our cosmic neighborhood was still taking shape, when the sun was newly ignited and surrounded by a disk of gas and dust and growing planetesimals, the building blocks of worlds. In this disk, closer to the sun where Mercury was forming, conditions were extreme. The intense heat from our young star would have vaporized lighter elements and compounds, driving them outward, leaving primarily heavier materials like iron and rock in the inner regions. Mercury would have coalesced from this metal-rich material, growing through countless collisions of smaller bodies, each impact adding to its mass, its gravity, its identity as a world. But there's another possibility, a more dramatic origin story. Some scientists propose that Mercury was once larger, perhaps much larger, with a thick, rocky mantle surrounding its iron core, more proportional to other rocky planets. And then, early in its life, it suffered a catastrophic collision. An object, perhaps a sixth of Mercury's mass, traveling at tremendous speed, struck the planet in a glancing blow. The impact would have been so energetic that much of Mercury's rocky mantle would have been vaporized or blasted into space, leaving behind the dense iron core and only a thin shell of rock. The debris might have formed a temporary ring around Mercury or scattered throughout the inner solar system, eventually swept up by other bodies or drawn into the sun. What remained was the Mercury we know today, compact and metal-rich, a remnant world, forever changed by that ancient violence. We don't know which story is true. Perhaps it was some combination of both, formation and catastrophe, shaping this small world into its current form. As you stand on this imagined Mercury morning, watching that slow sunrise, you'd notice something else unusual. The stars don't twinkle here. Earth's atmosphere, that thin blanket of gases that makes our world livable, also bends and distorts starlight. creating the twinkling effect we find so beautiful. Mercury has no such atmosphere to speak of, only the faintest wisp of atoms barely held by its weak gravity, an exosphere so tenuous it's essentially a vacuum. The stars would be steady points of light in an absolutely black sky, even with the sun above the horizon. During Mercury's long day, the sky remains dark except for the fierce light of the sun itself. No blue, no clouds, no atmospheric scatter of light, just blackness and stars and that burning sphere. The sun itself would appear larger from Mercury's surface, about 3 times larger in diameter than it appears from Earth, filling more of the sky with its presence. During perihelion, when Mercury swings closest to the Sun in its elliptical orbit, coming within just 29 million miles, the Sun would appear even larger, and the temperature would soar. During aphelion, when Mercury reaches the farthest point in its orbit, 43 million miles from the Sun would appear smaller and the temperature would drop, relatively speaking. This dance of distance creates, while temperature swings throughout Mercury's long day and year. Speaking of temperature, imagine the extremes this little world endures. At noon on Mercury's equator, the surface temperature can reach 800 degrees Fahrenheit, hot enough to melt lead, hot enough to glow if you could see heat as light. The ground would radiate that heat like an oven, and any unprotected material would quickly fail under such conditions. But because Mercury has virtually no atmosphere to distribute or retain heat, and because its day is so long, the night side of the planet becomes unimaginably cold. When the sun finally sets after those many months, the temperature plummets to nearly 300 degrees below 0 Fahrenheit. It's one of the most extreme temperature ranges in the entire solar system, over 1,000 degrees difference between day and night. A world of fire and ice, depending only on whether the sun faces you or has turned away. Yet even in these extremes, there are surprises. Deep within some of Mercury's polar craters, where the sun never reaches, where shadows have remained unbroken for billions of years, scientists have discovered something unexpected. Ice, water ice, along with other frozen volatile compounds, preserved in these permanent shadows like memories locked in darkness. These craters are deep enough and angled such that sunlight never touches their floors, and in this perpetual shade, temperatures remain cold enough to preserve ice indefinitely. The water likely came from comets that struck Mercury long ago, or perhaps from chemical reactions involving hydrogen from the solar wind and oxygen bound in Mercury's rocks. When these molecules found their way into the shadowed craters, they froze and stayed frozen, time capsules of cold in one of the hottest neighborhoods in the solar system. It's a beautiful reminder that even in extremes, even in the most unlikely places, conditions can arise for preservation, for gentleness, for the unexpected. The craters themselves tell stories, thousands upon thousands of them, each one a moment of impact, frozen in stone. Mercury's surface is heavily cratered, much like our moon, a record of the solar system's violent past. In the first billion years after the planets formed, a period called the Late Heavy Bombardment, the inner solar system was swept by countless asteroids and comets, remnants from the system's formation that had not yet found stable orbits or been absorbed by the growing planets. These objects rained down on the young worlds, and each impact on Mercury's surface blasted out a crater, throwing up walls of rock creating rays of ejected material that spread across the landscape like frozen splashes. The largest impacts created basins hundreds of miles across, and the force of these collisions was so great that it sent seismic waves rippling through the entire planet, focusing on the opposite side and creating strange, chaotic terrain there. Jumbled hills and valleys formed by shaking from within. One of Mercury's most prominent features is the Caloris Basin, a massive impact crater about 900 miles in diameter, large enough to contain the entire state of Texas. Caloris means heat in Latin, named so because it lies near one of Mercury's two hot poles, the 2 points on the equator that face the sun most directly at perihelion. When Mariner 10 first photographed part of the Caloris Basin in the 1970s, scientists could see it was something special, but only half of it was in sunlight, the other half hidden in darkness. It wasn't until the Messenger spacecraft orbited Mercury, decades later, that we saw the entire structure. The impact that created Caloris was so powerful, it didn't just blast out a crater. It created concentric rings of mountains, flooded the basin floor with lava that welled up from below, and sent that seismic shock through the planet that created the chaotic terrain on the opposite side. Standing at the center of Caloris Basin, you would be surrounded by distant mountains in all directions, an ancient scar on an ancient world, a reminder of energies we can barely imagine. Between the craters, across the plains, Mercury's surface shows features called scarps, or rupees in the Latin terminology that planetary scientists prefer. These are long, winding cliffs, sometimes hundreds of miles long and miles high, snaking across the landscape like frozen waves. They formed as Mercury cooled over billions of years. Remember that enormous iron core? As it cooled and solidified, it contracted, shrank slightly, and the rocky crust above it had to adjust to fit around a smaller interior. The planet wrinkled, essentially, like a grape becoming a raisin, and these wrinkles became the scarps we see today, thrust faults, where one section of crust was pushed up and over another. It's a beautiful geological metaphor, this idea that even planets show the signs of aging, of shrinking with time, of adjusting to their changing circumstances. Let's drift forward now through time, through the long silence of Mercury's existence, billions of years where it circled the sun in its swift orbit, where impacts gradually became less frequent, where the surface cooled and contracted and found its current form. For most of human history, Mercury was just a bright point of light in the sky, appearing briefly before sunrise or after sunset, never visible in the dark night because it stays close to the sun from our perspective. Ancient astronomers tracked it carefully, but they could see no details, no surface features, just that steady bright point moving against the stars. It wasn't until the invention of the telescope in the 1600s that anyone could see Mercury as more than a point of light, and even then, its closeness to the sun and its small size made it difficult to observe. Galileo tried to observe Mercury in the early 1600s, but likely never resolved it as more than a very small disk. Later, astronomers with better telescopes began to map what they thought they saw on Mercury's surface. Though these early maps were largely incorrect, artifacts of the difficulty of observing so close to the sun's glare, where Earth's atmosphere distorts the image and the brightness makes seeing details nearly impossible. For a long time, Astronomers believed Mercury was tidally locked to the Sun, always showing the same face to it, just as the Moon always shows the same face to Earth. It seemed logical given Mercury's close proximity to the Sun's gravitational pull. This belief persisted until the middle of the 20th century, when radar observations revealed the truth. Mercury does rotate, just slowly, in that unusual 3-to-2 spin-orbit resonance, where it rotates 3 times for every 2 orbits around the Sun. Humanity's first close-up glimpse of Mercury came from Mariner 10, a spacecraft launched by NASA in 1973. Mariner 10 was a pioneer in many ways, the first spacecraft to visit Mercury, the first to use a gravitational assist from another planet, flying by Venus to adjust its trajectory toward Mercury. It made 3 flybys of Mercury in 1974 and 75, photographing about 45% of the planet's surface and revealing a moon-like world covered in craters. The images sent back to Earth were grainy by modern standards, black and white, but they were revelations, our first true look at the innermost planet. Scientists saw the Caloris Basin, though only partly illuminated. They measured Mercury's magnetic field, surprisingly strong for such a small world with such slow rotation. They confirmed the lack of a substantial atmosphere, and then Mariner 10 ran out of maneuvering fuel, and Mercury faded back into partial mystery, half explored, waiting. For more than 30 years, no spacecraft visited Mercury. Other missions went to Mars, to the outer planets, to asteroids and comets, but Mercury remained untouched. Too difficult to reach perhaps, too close to the Sun, requiring too much energy to slow down enough to enter orbit rather than just flying past. But finally, in 2004, NASA launched MESSENGER, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, an acronym crafted with care. MESSENGER took a long, winding path to Mercury, using gravitational assists from Earth once, Venus twice, and Mercury itself 3 times, gradually shedding velocity, spiraling inward until it could finally enter orbit around Mercury in March of 2011. It was the first spacecraft to orbit Mercury, and it spent 4 years there, mapping the entire surface in extraordinary detail, measuring the planet's composition, studying its magnetic field, discovering that water ice in the polar craters, sending back thousands upon thousands of images until finally, in April 2015, having exhausted its fuel, MESSENGER made one last contribution to science by crashing into Mercury's surface, creating a new crater, a small human mark on an ancient world. The images and data from MESSENGER transformed our understanding of Mercury. We saw the entire surface now, not just 45%. We saw colors, subtle variations in composition that revealed Mercury's geological history in more detail. We saw volcanic plains that had flooded ancient craters, evidence that Mercury was once geologically active, with lava welling up from below to resurface parts of the planet. We saw those scarps in their full glory, winding for hundreds of miles, some cutting through craters, proving they formed after the crater impacts, giving us a relative timeline of Mercury's evolution. We learned that Mercury's magnetic field, though much weaker than Earth's, is indeed global and likely generated by a partially liquid outer core surrounding a solid inner core, much like Earth's own magnetic field generation system. For such a small world with such slow rotation, Having any magnetic field at all is remarkable, a sign that Mercury's interior is more complex and active than anyone expected. Right now, there's another spacecraft on its way to Mercury, a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency called BepiColombo, named after Giuseppe Colombo, an Italian mathematician and engineer who helped design Mariner 10's trajectory. Launched in October 2018, BepiColombo is taking an even more complex route to Mercury than Messenger did, using multiple gravitational assists to gradually approach the planet. It won't enter orbit until 2025, and once there, it will actually split into two separate orbiters, one focusing on mapping the surface and geology, the other studying Mercury's magnetic field and the space environment around the planet. Together, they'll spend at least a year gathering data, building on what Messenger taught us, answering new questions, and certainly raising even more. By the time BepiColombo completes its mission, we'll know Mercury more intimately than we ever have, this small world that has fascinated us for millennia. But even with all we've learned, Mercury keeps some of its mysteries close. Consider those volcanic plains that Messenger revealed. On Earth, volcanic activity is driven by plate tectonics and the decay of radioactive elements in the mantle that keep the interior hot and partially molten. Mercury is much smaller than Earth, and smaller planets lose their internal heat faster because they have less volume relative to surface area. By most calculations, Mercury should have cooled off completely billions of years ago, becoming geologically dead. Yet the evidence suggests volcanic activity continued perhaps until as recently as 3.5 billion years ago, maybe even more recently. Some scientists propose that Mercury's large iron core played a role, that as it cooled and solidified, it released heat that drove volcanism. Others suggest the core's composition, perhaps containing sulfur or other light elements mixed with the iron, allowed it to remain partially molten, longer than pure iron would. We're still piecing together the story, still learning how small worlds maintain internal heat and geological activity. There's also the question of Mercury's formation and early history. Was it always small and dense, or did it lose much of its rocky mantle in a giant impact? The answer matters because it helps us understand not just Mercury, but the early solar system as a whole, the violence of planetary formation, the role of impacts in shaping worlds. Messenger's measurements of Mercury's composition support both theories to some degree. The surface is low in iron compared to what you'd expect if the metallic core was simply exposed or very close to the surface, suggesting that the rocky mantle, though thin, is indeed rock and not just a thin veneer over metal. But the overall density still demands that huge core, and explaining how it got that way remains an active area of research. Perhaps future missions will find the definitive answer, or perhaps Mercury will keep this secret a while longer, as is its right. Imagine drifting in space again, watching Mercury complete its orbit, speeding around the sun while rotating slowly, that odd dance of motion that creates its long days and nights. From this distance, you can see the whole planet at once, a grey-brown sphere marked with the scars of time, bright rays extending from some younger craters where fresh material was excavated, darker patches where ancient lava flowed. It's not a colourful world Like Earth, with its blue oceans and white clouds and green life, is not even as colorful as Mars, with its rusty reds and dusty oranges. Mercury is subtle, shades of grey and brown and tan, variations in mineralogy and weathering creating a palette of stone and dust and ancient heat. But there's beauty in that subtlety, in the honesty of a surface that shows its age, that doesn't hide its history beneath water or air or life. Mercury is a world reduced to essentials: rock and metal and time and the unrelenting presence of the sun. Think about the sun for a moment, from Mercury's perspective. Our star is the dominant feature in Mercury's existence, more than twice as large in Mercury's sky as in ours, pouring down radiation and heat, creating those extreme temperature swings, stripping away any atmosphere that might try to form, bathing the surface in light and solar wind. The solar wind is a stream of charged particles, mostly protons and electrons, flowing out from the sun's corona at hundreds of miles per second, filling the solar system with a thin plasma. On Earth, our magnetic field and atmosphere protect us from the solar wind, deflecting most of it around the planet, creating the magnetosphere, the Van Allen radiation belts, and sometimes, when the solar wind is particularly strong, the auroras that dance in polar skies. Mercury too has a magnetosphere, created by its weak but present magnetic field. And this magnetosphere interacts with the solar wind in complex ways. Because Mercury's magnetic field is so much weaker than Earth's, and because Mercury is so close to the Sun, where the solar wind is stronger, the interaction is more dramatic. The solar wind compresses Mercury's magnetosphere on the day side, pushing it close to the surface, and stretches it out into a long tail on the night side. Sometimes, the solar wind overwhelms Mercury's magnetic field temporarily, allowing particles to strike the surface directly, sputtering atoms off the rock, contributing to the thin exosphere. These sputtered atoms, along with atoms released by solar heating and micrometeorite impacts, create a tenuous cloud around Mercury, mostly sodium, potassium, calcium, and magnesium, elements that can be detected from Earth with sensitive spectrographs. This exosphere is constantly being lost to space and constantly being replenished, a dynamic equilibrium between loss and renewal, a thin memory of a world that once might have had a thicker atmosphere when it was young and volcanic. If you could see Mercury's exosphere with your eyes, which you can't because it's far too tenuous, it would be a faint glow around the planet, brightest where solar wind or sunlight is striking the surface most directly, creating and energizing these atoms. Some of these atoms are ionized by sunlight, gaining an electric charge, and then picked up by Mercury's magnetic field and the solar wind, accelerated away from the planet into space, eventually joining the solar wind flow, or perhaps striking another world downstream. It's a kind of slow erosion, the sun gradually wearing away at Mercury over billions of years, atom by atom, grain by grain, an erosion so slow as to be almost imperceptible, yet over deep time, significant. Let's travel across Mercury's surface now, drifting from region to region, exploring the diversity of terrain that MESSENGER revealed. In the northern polar region, you'll find large areas of smooth plains, ancient lava flows that filled in low-lying areas billions of years ago. These plains are punctuated by craters of various sizes, some fresh with bright rays, others ancient and barely distinguishable, softened by eons of micrometeorite bombardment. As you move toward the equator, the terrain becomes more varied. a mix of heavily cratered highlands, intercrater plains, and those long scarps winding across the landscape. One of the most prominent scarps is called Discovery Rupees, over 400 miles long and over a mile high in places, a towering cliff that cuts through craters and plains alike, a testament to Mercury's contraction as it cooled. In the equatorial regions, you encounter some of the hottest places in the solar system, the areas that face the sun most directly during perihelion, where temperatures climb to those 800-degree peaks. The rock here has been baked and rebaked countless times over billions of years, thermal cycling creating stresses that cause the surface to crack and weather in unique ways. If you could examine a rock from Mercury's hottest regions under a microscope, you'd see textures and structures created by extreme temperature gradients, expansion and contraction, a geological record of endurance. Moving into the southern hemisphere, you find more heavily cratered terrain, ancient surfaces that have remained largely unchanged since the late heavy bombardment. Here, too, you find large impact basins, though none quite as prominent as Caloris. One of these southern basins shows evidence of volcanic flooding similar to Caloris, suggesting that Mercury's early volcanism was widespread, not limited to one region. These volcanic plains are darker than the surrounding terrain, lower in reflectivity, possibly richer in iron or titanium, minerals that affect color and brightness. By mapping these color and brightness variations across the entire planet, scientists can infer the composition and history of different regions, piecing together Mercury's geological story like a vast puzzle made of stone and time. And then there are Mercury's hollows, one of the most unexpected discoveries from MESSENGER. These are small, irregular depressions in the surface, often found within craters or on crater walls, with bright, relatively fresh-looking interiors. They appear to be areas where material has been lost, perhaps sublimated away or removed by some process related to solar radiation. The leading theory is that certain minerals in Mercury's crust, possibly sulfides or volatile-rich compounds, are unstable under the intense sunlight and space weathering conditions, and they gradually disappear, leaving behind these shallow hollows. If true, it means Mercury's surface is still actively changing, even today, not through tectonics or volcanism, but through this slow process of loss, of evaporation, of subtle erasure. The hollows give Mercury's surface a delicate, almost fragile appearance in close-up images, as if the planet is slowly evaporating into space, which in a sense it is, one molecule at a time. Perhaps the most philosophically interesting aspect of Mercury is its relationship with time. Because of that 3:2 spin-orbit resonance, Mercury experiences something called a double sunrise at certain locations. If you are standing at one of Mercury's hot poles, the two equatorial points that face the sun at perihelion, and you watch the sunrise, you'd see the sun climb partway above the horizon, then stop, then actually reverse direction and set again briefly, before rising once more to continue its long climb across the sky. This happens because Mercury's orbit is elliptical, and at perihelion, its orbital speed briefly exceeds its rotational speed from the perspective of someone standing on the surface. The sun appears to hesitate, then backtrack, a cosmic do-over before proceeding. It's as if time itself becomes uncertain at these locations, as if the universe is reconsidering its path forward, however briefly. This resonance wasn't always the case. When Mercury first formed, it likely rotated faster, perhaps with a rotation period of just hours like most planets start with. But over billions of years, the Sun's gravity exerted tidal forces on Mercury, creating bulges in the planet and friction between the crust and interior, gradually slowing the rotation. In most cases, tidal forces eventually lock a small body into showing the same face to its companion as the Moon does to Earth. But Mercury's orbit is eccentric enough that a one-to-one tidal lock isn't the most stable configuration. Instead, Mercury settled into this 3-to-2 resonance, a gravitational sweet spot where the tidal forces balance out over time, where the rotation and orbit synchronize in this unusual ratio. It's a delicate balance, a dance between gravity and motion and time, and Mercury performs it perfectly, orbit after orbit, decade after decade, eon after eon. Consider what this means for a hypothetical observer standing on Mercury's surface, one who could somehow survive the conditions and stand there for years. The sun would rise, enormous and bright, and climb slowly across the black sky. Stars would wheel around it, unblinking as days passed. The sun would reach its peak, then begin its descent, taking months to cross from horizon to horizon. Finally, sunset, and then darkness, and the temperature would plummet, and the stars would become the only light, along with the zodiacal light, a faint glow from dust in the inner solar system, reflecting sunlight. For months, this darkness and cold would persist, the night side of Mercury facing away from the sun, feeling only the faint warmth of distant stars. And then, eventually, the sun would begin to rise again, and the cycle would repeat. It's a rhythm so slow it barely feels like rhythm at all, more like a gradual transition between states, a cosmic breathing, inhale and exhale measured in seasons that stretch across months. There's something meditative about contemplating Mercury's timescale, how different it is from our own. We live our lives in days of 24 hours, a pace set by Earth's rotation. Our months are roughly based on the Moon's cycle, our years on Earth's orbit. These timescales shape our experience, our culture, our biology. But Mercury operates on a different clock, one where a single day contains 2 of its years, where seasons are measured not by axial tilt, but by distance from the sun as it moves through its elliptical orbit. If humans ever visited Mercury, we'd have to invent new ways of thinking about time there, new calendars and schedules that acknowledge the planet's unique rhythm. Perhaps we'd mark time by orbits, or by the passage of sunlight across particular craters, or by the changing size of the sun in the sky as Mercury moved from perihelion to aphelion and back. We'd learn to slow down, to think in longer spans, to appreciate patience on a cosmic scale. Speaking of humans visiting Mercury, it's worth pondering what that would take. Mercury is, in many ways, one of the most challenging places in the solar system to visit. The closeness to the sun means any spacecraft or habitat would need extraordinary thermal protection to survive the daytime heat. The lack of atmosphere means no aerobraking to slow down on arrival, no parachutes for landing, only rockets burning fuel. The low gravity, about 38% of Earth's, is similar to Mars, manageable but strange, enough to keep you anchored but light enough to make movement feel different, slightly floaty, requiring adjustment. The radiation environment is harsh, both from the sun's light and from the solar wind. and getting there requires a lot of energy, not to speed up necessarily, but to slow down enough to match Mercury's orbital velocity and enter orbit or land, because you're falling toward the sun the whole way, accelerating, fighting against the sun's enormous gravity well. But despite these challenges, Mercury does have some advantages. The abundance of metals in its crust, including iron and other valuable elements, could be useful for future space industry. The intense sunlight, though dangerous, is also an abundant energy source. Solar panels would be incredibly efficient on Mercury's day side, at least until the heat destroys them. The polar craters with their water ice could provide resources for life support or fuel production. And from Mercury, the sun would be a spectacular laboratory, close enough to study in detail, with instruments that could observe solar phenomena impossible to see from Earth's distance. Mercury could become a scientific outpost for solar physics, perhaps, protected in permanently shadowed craters or in underground habitats, venturing out onto the surface only during the cooler dawn or dusk periods, or using advanced cooling systems to endure the heat. But that's all speculation, dreams of futures that may or may not come. For now, Mercury remains untouched by human presence, visited only by our robotic emissaries, observed only from afar. And perhaps that's fitting. Mercury has existed for 4.5 billion years in relative solitude, circling the sun, enduring its extremes, quietly persisting. It doesn't need us. It's complete as it is, a world unto itself, a small, dense sphere of metal and rock, doing what it has always done, orbiting, rotating, existing. There's a kind of grace in that, in a world that simply is, without requiring anything from anyone, without expectation or need. Let's think about Mercury in the context of the solar system as a whole. It's the innermost planet, but it wasn't always alone in the inner regions. Theories of solar system formation suggest that many planetesimals, the building blocks of planets, formed in the inner solar system. Most were swept up by the growing Earth, Venus, Mars, and Mercury, or ejected to the outer system or into the Sun itself. Some became the asteroids that still orbit in the belt between Mars and Jupiter, remnants that never coalesced into a planet. Mercury is what survived in the innermost region, what endured the most intense environment, the strongest solar heating, the most frequent collisions in the early chaotic days. It's a survivor in its way, the last one standing closest to the fire. The inner solar system is sometimes called the terrestrial zone, home to the 4 rocky planets: Mercury, Venus, Earth, and Mars. Each of these worlds formed from similar materials, rocky silicates and metals, but each evolved so differently based on size, distance from the Sun, and chance events in their histories. Venus, nearly Earth's twin in size, became a hellish greenhouse world with crushing atmospheric pressure and temperatures hot enough to melt lead across its entire surface. Earth found a temperate middle ground with liquid water and plate tectonics, and eventually life, intelligence, consciousness. Looking back at the cosmos, Mars, smaller and farther out, lost most of its atmosphere and water, becoming a cold desert world, but one that still holds secrets about past habitability. And Mercury, smallest and closest, became this stripped-down essential world, a sphere of metal barely wrapped in stone, enduring the sun's presence with patient silence. These 4 worlds are siblings, born from the same nebular cloud, yet their fates diverged so completely. It's a reminder that initial conditions matter profoundly, that small differences in location or size or composition can lead to vastly different outcomes over billions of years. If Earth had formed just slightly closer to the Sun, would we have become another Venus? If Mercury had formed with more mass, could it have held an atmosphere, developed differently, perhaps even been a place where something like life could have emerged in protected regions? We can't know these alternate histories, but contemplating them helps us appreciate how remarkable our own world is. How many factors had to align just so to create a planet where liquid water could persist, where chemistry could become biology, where complexity could arise and flourish? From Mercury's perspective, if such a world could have perspective, Earth might seem impossibly distant and cold, orbiting out there where the sun is smaller and dimmer, where water doesn't immediately boil away, where the temperature ranges are gentle enough for complex chemistry. Mercury knows heat and cold, but not the temperate zone, not the liquid range of water, not the conditions that allow for the intricate dance of life. And yet, Mercury's existence contributes to the stability of the entire inner solar system. Its gravity, though weak, is still significant on solar system scales, and it contributes to the gravitational choreography that keeps the orbits of all the planets relatively stable over millions of years. Remove Mercury, and the orbital dynamics would change in subtle but potentially important ways over deep time. Every world matters. Every mass contributes to the whole, even the smallest planet circling closest to the fire. There's a mathematical elegance to planetary orbits that humans have been discovering for centuries. Johannes Kepler, in the early 1600s, derived his 3 laws of planetary motion by carefully analyzing the observations of Mars made by Tycho Brahe. These laws describe how planets move. They orbit in ellipses with the sun at one focus. They sweep out equal areas in equal times as they orbit, and the square of their orbital period is proportional to the cube of their average distance from the sun. These laws apply to all the planets, including Mercury, and they were revolutionary because they replaced the old idea of circular orbits with the more accurate elliptical paths. Mercury's orbit is the most elliptical of all the planets, with an eccentricity of about 0.2, meaning its distance from the Sun varies significantly as it orbits. This eccentricity creates those temperature swings, that changing apparent size of the Sun in Mercury's sky, those complex resonances between rotation and revolution. But there's something even more interesting about Mercury's orbit, something that troubled astronomers for decades and helped confirm one of the most profound scientific theories ever developed. Mercury's orbit precesses, meaning the ellipse itself slowly rotates in space over time, so that the point of closest approach to the Sun, the perihelion, gradually shifts position. All orbits precess to some degree due to gravitational influences from other planets, and astronomers could account for most of Mercury's precession using Newton's laws of gravity. But not all of it. There was a tiny discrepancy, just 43 arcseconds per century, a minuscule amount, less than 2/100th of a degree per century. Yet it was measurable, and it was unexplained by Newtonian physics. Some astronomers proposed the existence of another planet, closer to the Sun than Mercury, whose gravity could account for the extra precession. They even gave this hypothetical planet a name, Vulcan, after the Roman god of fire, fitting for a world so close to the sun. Searches were conducted. Observers looked for transits of Vulcan across the sun's face, but the planet was never found because it didn't exist. The answer came from an entirely different direction, from Albert Einstein's general theory of relativity, published in 1915. Einstein's theory described gravity not as a force acting across distance, but as a curvature of space-time itself. Massive objects bending the fabric of space and time around them. In this framework, planets don't orbit because they're pulled by a force, but because they're following the straightest possible paths through curved space-time, like marbles rolling on a curved surface. When Einstein applied his equations to Mercury's orbit, the extra precession appeared naturally in the calculations. The sun's mass curves space-time so strongly in Mercury's vicinity, especially at perihelion when Mercury is closest, that the path Mercury follows is slightly different from what Newton's simpler equations predicted. The difference is tiny, but it's exactly the 43 arcseconds per century that astronomers had measured. This was one of the first major confirmations of general relativity, and it's often cited as evidence that our universe operates according to Einstein's geometric vision rather than Newton's action at a distance gravity. Mercury, in its lonely orbit, was helping humanity understand the fundamental nature of reality, space-time, gravity, the structure of the cosmos. This small world, doing nothing more than orbiting the sun as it always had, became a testing ground for our deepest theories about existence itself. It's humbling, in a way, to realize that the universe doesn't arrange itself for our convenience or understanding. Mercury doesn't care about relativity or classical mechanics, doesn't know it's confirming scientific theories. It simply follows the path that space-time offers, orbiting, existing, being. And yet, by observing it carefully, by measuring its motion with precision, by questioning the small discrepancies between observation and theory, humans learned something profound about the nature of space, time, and gravity. This is the power of science, the patient observation, the careful measurement, the willingness to follow where the evidence leads, even when it challenges our understanding. Mercury was the same before and after Einstein, but our comprehension of the cosmos deepened because we paid attention to its motion. Let's return to the surface now, to that imagined standing point on Mercury's equator, and think about what it would be like to witness the passage of time there. Suppose you arrived during dawn, just as the sun was beginning its slow climb above the eastern horizon. You've positioned yourself in a sheltered location, perhaps a crater wall that provides some shade, with instruments to monitor the temperature and radiation levels. As the sun rises, you watch its enormous disk emerge, 3 times larger than the sun appears from Earth, blindingly bright, its surface showing the granulation patterns and occasional dark spots that mark active regions. The temperature around you begins to climb, slowly at first, then more rapidly as more of the sun clears the horizon and its light strikes the ground more directly. Hours pass, then days by Earth's reckoning, and the sun continues its climb. The surface temperature rises from the bitter cold of night to a brief, pleasant range, and then into uncomfortable heat, then dangerous heat, then extreme heat that your shelter barely protects against. The rocks around you begin to radiate their absorbed energy, glowing faintly in the infrared spectrum if you could see it. Weeks pass, and the sun reaches its zenith directly overhead, a blazing sphere filling the black sky with light. At this moment, on the day side of Mercury, you're experiencing one of the most intense solar radiation environments in the solar system. The sunlight is not just bright, it's concentrated, energetic, pouring down without any atmosphere to filter or diffuse it. If you stepped out of your shelter, your protective gear would immediately begin to heat up, the material stressed by the temperature gradient between the side facing the sun and the side facing away. More time passes, the sun begins its descent toward the western horizon, the process reversing. The temperature gradually drops as the angle of sunlight becomes less direct. Finally, after months, the sun touches the western horizon and begins to set, taking many hours to disappear completely. As darkness falls, the temperature plummets rapidly, heat radiating away into space with no atmosphere to hold it close. The stars emerge in full glory, and the Milky Way arcs across the sky, a river of distant suns, our galaxy seen edge on. Billions of stars too far away to provide any meaningful warmth, but beautiful in their multitude. Earth would be visible at certain times, a bright blue-white star in the sky, sometimes accompanied by a fainter point nearby, the Moon. Venus would be brilliant, Mars a reddish point, Jupiter steady and bright, Saturn dimmer, but still visible to the unaided eye if you had eyes and could survive to use them. The planets and stars wheel overhead through the long night, the celestial sphere rotating because Mercury, though slowly, is still spinning. If you could survive to witness it, you'd see the zodiacal light, a faint triangular glow along the plane of the solar system, caused by sunlight reflecting off the dust that fills the space between planets. This dust is made of tiny particles, remnants of comets and asteroids, material that never coalesced into larger bodies, and it orbits the sun in a disk roughly aligned with the planet's orbits. From Mercury, closer to the sun and the densest part of this dust cloud, the zodiacal light would be brighter than it appears from Earth, a ghostly reminder of the sun's presence even in the night sky. And if you were very lucky, you might witness a comet, one of those icy wanderers from the outer solar system, diving in toward the sun, growing a tail as it heats up, passing through Mercury's vicinity on its elliptical journey. Comets have struck Mercury countless times over its history, contributing water and organic compounds to the surface, occasionally creating craters, always adding their small mass to the planet's total. Each impact is a meeting of two ancient objects, one forged in heat close to the sun, the other in cold far from it, brought together by gravity and chance. As the long night continues, you'd have time to think, to contemplate, to feel the stillness of this place. Mercury's night side is perhaps one of the quietest places in the solar system. No wind, because there's no atmosphere, no weather, no rain, no storms, no erosion except the incredibly slow process of micrometeorite bombardment and thermal stress. No life, no movement except the slow turn of the planet itself and the occasional impact of a tiny space pebble. Just rock and darkness and the distant stars and the patient passage of time. It's a kind of peace, if you could appreciate it, a silence so complete it might feel overwhelming, or it might feel like a gift, depending on your nature. In a universe often violent and chaotic, Mercury's night side offers a respite, a place where nothing happens for months at a time, where existence is reduced to the simplest terms: matter, energy, space, time. Eventually, the sun would rise again, and the cycle would repeat. This is Mercury's life, has been for billions of years, will be for billions more, until the sun itself begins to die, swelling into a red giant in about 5 billion years, engulfing Mercury entirely, finally ending the little planet's long vigil. But that ending is so far in the future, it might as well be forever from Mercury's perspective. If worlds could have perspectives, if time felt the same to stone as it does to consciousness. For now, Mercury orbits and rotates and endures, and that is enough. Think about the elements that make up Mercury, the atoms that comprise its mass. Every atom heavier than hydrogen and helium was forged in the nuclear furnaces of stars that lived and died before our solar system formed. The iron in Mercury's core, the silicon and oxygen in its rocky mantle, the trace elements scattered through its composition, all were created through nuclear fusion in stellar cores or in the catastrophic explosions of supernovae. When those ancient stars exhausted their fuel and collapsed or exploded, they scattered these elements into space, enriching the interstellar medium with the building blocks of planets and life. Our solar system formed from a molecular cloud that contained these elements, a nebula perhaps triggered into collapse by the shockwave from a nearby supernova. And as it collapsed and spun, it formed the sun and the planets and all the smaller bodies. Mercury is made of stardust, as is Earth, as are you. We're all recycled star material, rearranged into new forms, planets and people, rock and thought, matter becoming aware of itself through the unlikely process of evolution and consciousness. When you look at Mercury, small and grey and scarred, you're looking at a collection of atoms that once existed inside other stars, that travel through space for who knows how long, that found each other and assembled through gravity into this particular configuration, this planet. Those atoms will persist essentially forever, or at least until the distant heat death of the universe renders all atoms into their lowest energy states. Even when the sun engulfs Mercury, the atoms will merely be dispersed, perhaps falling into the sun, perhaps scattered into space to eventually become part of something else, another stellar system forming billions of years hence. Matter persists. Form changes. Mercury is a temporary arrangement, though one that has persisted 4.5 billion years and will persist several billion more. It's a long time by any human measure, long enough to seem permanent, yet cosmically it's fleeting, a moment in the universe's vast duration. There's a philosophical tradition of contemplating impermanence, of recognizing that all things change and end, and finding peace in that recognition rather than fear or sadness. Mercury embodies this teaching. It was formed from a nebula, grew through accretion, was possibly struck and transformed, cooled and contracted, was bombarded by impacts that scarred its surface, hosted volcanic activity that eventually ceased and continues now in a quasi-stable state until the sun's evolution changes everything again. Nothing about Mercury is truly permanent, except the atoms themselves, and even those will one day return to the universe's general dispersal. Yet Mercury's existence right now is real and complete. It's not less valuable because it will end. It's not less beautiful because it's temporary. It simply is what it is, when it is, and that's enough. Perhaps That's the deepest lesson Mercury offers us, if we're willing to receive it. Not lessons about planetary formation or orbital mechanics or relativity, though those are valuable too, but the simple lesson of existence without fanfare, of being without needing to be noticed or celebrated or understood. Mercury doesn't proclaim itself. It doesn't reach out. It quietly orbits the sun, reflects some light, absorbs most of it as heat, rotates slowly, and continues. It asks nothing. It offers what it is to those patient enough to look, to study, to wonder. In our busy lives, full of noise and distraction and constant stimulation, there's something valuable in contemplating Mercury's silent endurance, its patient existence, its completeness without need for validation. We live in an age where humans have sent machines to every planet in our solar system, where we've landed on asteroids and comets, where we've even sent probes beyond the solar system into interstellar space. We've photographed distant galaxies, detected gravitational waves, sequenced our own genome, built machines that can think in ways that mimic consciousness. It's an extraordinary time to be alive, to witness humanity's expansion of knowledge and capability. And yet, for all our achievements, we're still bound to this one planet Earth, still learning to be good stewards of our own world, still grappling with how to live sustainably and peacefully with each other and the biosphere that sustains us. Mercury reminds us of our scale. We're inhabitants of one planet among 8, orbiting one star among hundreds of billions in our galaxy, which is one galaxy among hundreds of billions in the observable universe. We're cosmically small, our existence brief, our influence limited to the tiniest fraction of space and time. But small doesn't mean meaningless. In the entire universe, as far as we know, Earth is the only place where matter has organized itself into life and consciousness. We're the universe's way of knowing itself, of reflecting on its own existence, of asking questions and seeking answers. That makes us rare, perhaps impossibly rare, perhaps unique. And it makes our existence precious beyond measure, not because we're physically large or long-lived, but because we're aware, because we can contemplate Mercury and wonder about it, because we can build spacecraft and send them across the solar system, because we can develop theories about gravity and time and test them against observation, because we can create art and music and stories and science and compassion and love. We're a way the universe has found to understand itself. And that's extraordinary, even if we're small, even if we're brief. So as you lie here in the darkness, breathing slowly, feeling your body relaxed and heavy, thinking about Mercury if you're still awake enough to think, or drifting into dreams that might carry echoes of what you've heard, remember that you're part of this same universe that made Mercury. The same fundamental forces that shape the solar system shape your cells, your thoughts, your dreams. The same atoms that comprise Mercury's iron core are in your blood, carrying oxygen to your tissues. The same quantum fields that underlie all reality underlie your consciousness right now, creating the experience of being you, reading or listening to this, existing in this moment. You're not separate from the universe, looking at it from outside. You're a pattern in the universe, an eddy in the cosmic flow, a temporary arrangement of matter and energy that has somehow become capable of wonder and rest and peace. The night around you is quiet now, or filled with gentle sounds, the breath of a partner, the hum of electronics, the distant murmur of a world that doesn't sleep even when you do. Somewhere above, if it's nighttime where you are, Mercury might be visible, a bright point in the twilight sky near the sun, hard to see but there, ancient and patient. Even if you can't see it, you know it's there now, circling the sun at its swift pace, experiencing its long days and nights, holding its secrets and its scars, simply being what it is. There's comfort in that knowledge, in knowing the universe continues its patterns, even when we're not watching, even when we're asleep, even when we've forgotten it exists. The planets orbit, the stars shine, the galaxies spiral, and all of it happens whether we pay attention or not. It's not for us, but we can witness it, can appreciate it, can find peace in our smallness within its vastness. Your breathing has slowed now, each breath deeper and longer than the last. Your body sinking further into comfort, your mind quieting, thoughts becoming less distinct, more like impressions or feelings than complete ideas. This is how sleep approaches, gently, like dusk falling, like the sun setting on Mercury's long day, a gradual transition from wakefulness to rest. There's no need to force it, no need to hurry. Sleep will come when it comes, and if it hasn't come yet, that's fine too. You're comfortable, you're warm or cool as you prefer, you're safe in this space, and you have permission to simply rest, to exist without purpose or goal, to let time pass without marking it, to drift without direction. Mercury has become a kind of companion in your thoughts now, if you're still thinking, a small grey world keeping its own counsel, holding its station, enduring its extremes with grace. You've traveled to it in imagination, stood on its surface, watched its slow sunrise and long sunset, contemplated its history and its future, learned its secrets, and perhaps, in return, it's taught you something about patience, about endurance, about the value of quiet existence. Perhaps it's reminded you that you don't always have to be doing, achieving, striving, that sometimes simply being is enough, that rest is not laziness, but necessity, that sleep is not wasted time, but restoration, that the universe continues, whether you're participating actively or resting deeply. Let your mind release Mercury now. Let it drift away into the darkness of space, continuing its eternal orbit while you continue your own journey into sleep. You don't need to hold on to anything. Don't need to remember everything you've heard. Don't need to understand it all or make sense of it. The details can fade, the facts can blur, the images can dissolve. What remains is the feeling, the sense of having traveled somewhere vast and ancient and peaceful, the quiet satisfaction of wonder, the gentle tiredness that comes from contemplation and imagination, and the simple act of paying attention to something beautiful and strange and far away. Your body knows what to do now. It's been getting ready for sleep this whole time, producing the right chemicals, slowing the right processes, shifting into the right state. Your brain waves are changing, moving from the alert beta waves of daytime consciousness through the relaxed alpha waves into the drowsy theta waves that precede sleep. Soon, if not already, you'll slip into delta waves, the slow, deep oscillations of true rest, of sleep that restores and heals and processes and consolidates, that takes the experiences of the day and weaves them into memory and learning and growth. Sleep is not nothing. Sleep is everything. It's when your body repairs itself, when your mind integrates what it's learned, when your emotional system recalibrates, when you become ready for another day. And you deserve this sleep. You've earned it simply by being alive, by making it through another day, by existing in a universe that asks much of us all. The stories of Mercury are ancient, told by cultures around the world in different ways. The Babylonians called it Nabu, after their god of writing and wisdom, appropriate for a planet whose swift motion suggested quickness of thought. The ancient Greeks knew it as Apollo when it appeared in the morning sky, and Hermes when it appeared in the evening, before realizing these were the same object, one planet visible at different times. The Mayans called it Chak-ek, associated with warfare and sacrifice, its appearances timed with ceremony and ritual. In Hindu tradition, it's Buddha, not to be confused with Buddha, associated with intelligence and communication. Chinese astronomers called it Chen Xing, the hour star, because its appearance marked certain times. Indigenous Australian cultures incorporated it into their Dreamtime stories, seeing it as a character in the eternal narratives that explain the world's creation and structure. Every culture that looked up saw Mercury and wove it into their understanding of the cosmos, gave it meaning and mythology, used it to mark time and make sense of celestial patterns. These stories, diverse as they are, share something in common. They recognize Mercury as special, different from the other planets, moving more swiftly, appearing and disappearing, tied more closely to the sun than its siblings. Ancient people, without telescopes or spacecraft, without physics or mathematics as we know them, still understood something fundamental about Mercury through patient observation. They saw it was a messenger, a boundary crosser, a swift traveler, and they encoded that understanding in myth and story and tradition. We've refined that understanding now, replaced mythology with science, but perhaps we've lost something too: the personal connection, the sense that celestial objects are part of our human story, that they matter not just as physical objects, but as symbols and inspirations and companions in our journey through existence. What would it mean to recover that sense of connection while maintaining our scientific understanding? To see Mercury not just as a rocky planet with a large iron core and a highly elliptical orbit, but also as Hermes, swift messenger, boundary dweller, guide between worlds. Not literally, of course, but poetically, metaphorically, as a way of enriching our relationship with the cosmos. Perhaps that's part of what we're doing here tonight, weaving together the scientific and the poetic, the measured and the mythic, trying to see Mercury whole, as an object we can study and as a presence we can appreciate, both at once, neither excluding the other. Science gives us precision and understanding, but poetry gives us meaning and connection. We need both to be fully human, to engage with the universe not just with our intellects, but with our hearts and imaginations too. As you continue to rest here, sinking deeper into relaxation, closer to sleep, your breathing almost imperceptible now, slow and shallow and easy. Consider that you're part of a long lineage of humans who have looked at the night sky and wondered. Our ancestors, tens of thousands of years ago, saw the same stars we see, though from slightly different positions as the galaxy slowly turns. They saw Mercury too, noticed its motion, wondered about it, told stories to explain it. And in turn, their descendants, thousands of years from now, if humanity persists and thrives, will still see Mercury, will still wonder, will still seek to understand. You're a link in that chain, a moment in that continuity, connected backward to those ancient stargazers and forward to generations yet unborn. Your curiosity tonight, your willingness to learn about Mercury, to imagine it, to let it help you find peace and rest, is part of humanity's ongoing conversation with the cosmos. A conversation that has no end as long as we exist. Mercury itself doesn't know about this conversation, can't hear your thoughts or appreciate your interest. It's indifferent to whether we study it or ignore it, whether we visit it with spacecraft or never think of it at all. And that's fine. That's honest. The universe doesn't need our attention or approval. It existed for billions of years before humans appeared, and it will exist for billions more after we're gone, if we're gone. But while we're here, we get to look, to wonder, to learn, to appreciate, to find beauty and meaning in distant worlds and close ones, in the vast and the tiny, in the temporary nature of existence and the eternal patterns that shape it. That's our gift and our burden: consciousness, awareness, the ability to ask why and how and what if. And sometimes, the best use of that gift is simply to rest in wonder, to let questions float unanswered, to appreciate what is without needing to fully understand it, to sleep and dream and let the universe continue without us for a while. The room around you is so quiet now. You've been here for a long time, listening, thinking, drifting. Your body has let go of so much tension. Your mind has released so many of the day's concerns. You're nearly asleep, or perhaps you already are. The boundary between waking and sleeping so thin now, it barely exists. Your thoughts more like dreams. This voice just a murmur in the background. Words without much meaning anymore. Just sound and rhythm, and the suggestion of peace. That's perfect. That's exactly where you should be. Sleep is close now, right here, waiting for you to take that last step into it. And when you do, you'll find the rest you need, the restoration you deserve, the peace that comes from surrendering to your body's wisdom and your mind's need for darkness and quiet. Mercury orbits still, as it has, as it will. The sun burns, fusing hydrogen into helium, pouring light across the solar system, warming worlds, creating the conditions for existence, for Earth's life, for your breathing, for this moment. The solar system drifts through the galaxy, our sun and its family of planets and moons and asteroids and comets, all moving together at over 500,000 miles per hour relative to the galactic center. Though we don't feel that motion, can't perceive it, just as we don't feel Earth's rotation or its orbit. We're passengers on a cosmic journey we didn't choose and can't control. And all we can do is appreciate the ride, marvel at the views, take care of each other and our shared home, and rest when we need rest. So rest now, deeply, completely, without reservation. Let go of Mercury, let go of space, let go of thought itself. Just breathe and be and sleep. The universe holds you, the earth supports you, gravity keeps you grounded, and the darkness is your friend, welcoming you into its soft embrace. You've traveled far tonight, across millions of miles in imagination, across billions of years in thought. And now, you're home, here, safe, allowed to sleep, encouraged to dream, free to drift as deep as you need to go. Good night, traveler. Rest well. Tomorrow will come with its own light, but for now, there is only this quiet darkness, this peaceful moment, this gentle letting go. Mercury circles the sun. You circle into sleep, and everything is as it should be. Everything is enough. Everything is beautiful in its way. Close your eyes if they're not already closed. Take one more slow breath and release it completely. Let that breath carry you deeper still, into sleep's territory, into rest's kingdom, into the soft, dark place where healing happens and peace is found. And sleep now. Have a good night.